Okay, so welcome to everyone. This is our first class. This is basically how we will be handling data. So basics on crash course on top of the data engineering, rather we can say data scientist we can say also, but for data scientist, if we can if we have anyone to have our career, career aspiration to be a data scientist, then yeah, must we need to know the data engineering, how the data can be handled, what are the basic things to nurture the data, and also that thing should be covered by this courses. Okay, so what should we, going to be covered over there? So first of all, there should be one or two basic introductory classes till tomorrow. After that, we'll be learning SQL for 4 to 5 days. SQL means structured query language. So how to query on top of structural data or relational data. I'll be coming to what is SQL and SQL in today's session. So this thing we'll be learning for 5 days, starting from Wednesday. Okay. And after completion of SQL, we'll be learning what is the main motto of this data. The data engineering on based on business intelligence. So what is business intelligence and all? How we can make a unmeaningful data to meaningful data. So this kind of stuff we'll be learning in later 2 or 3 days session after SQL. After that, we'll be covering Python. Okay, Python as a basics for some days. It should be 3 4 days, and then Python should be used again as top of a data engineering tool. Okay, there we'll be using some Python extension, or rather we can say pandas or NumPy packages on top of Python. And after that, after completion of Python, there will be few more classes. It will be touched over here, just like some cloud computing part on top of AWS. Should be 2 to 3 days. A code-based repository part, that means on top of Git or GitHub, that should be covered for 1 or 2 more days. And a basic overview on top of big data, Hadoop, in next 2 to 3 days. So this is the overall coverage of that particular courses, and it should cover almost 1 month. And inside that, we'll be covering some more hands-on exercise on top of SQL and Python, so that you should be having quite good experience on top of solving exercises or solving real-time problems as well. And if you are willing to join any company on top of data engineering, or if you're already working in data engineering, then those exercises should be helpful. So each of the end of the courses will be going through this exercise. And after solving this, you can get into accustomed how that thing can be solved, and how easily you can do the sequels, and how easily you can understand the data. Okay. So today is very introductory class. So what is data? Specific, in this entire courses, we'll be handling only data, nothing else. So data is the collection of information, and the data can be describing, the information can be describing in quantity, quality, fact, statistics, whatever we are doing in our daily life, not only, in every aspect of industry. Okay, in every industry, they are collecting the data for analyzing their business growth. They're checking their past. They're trying to rectify the issue from their past by checking the data, so that the same issue will not be coming in their future. Okay. They're forecasting their business growth by the data. So statistics are playing a beautiful role, a crucial role in today's life. They're forecasting their business on helping of data scientists or data science. We can forecast what should be there in tomorrow based on these many days data or record. Okay. So in each of the industry, there are data, and those are very much important to run that particular business. Okay. So how that can be playing important business? The most of the thing we'll be covering in business intelligence session. What is the procedure? the normal procedure to, set up the data setup and everything. But today, let's quickly see what are the things. Okay, I found something in chat. Yeah. Hi, Samantha. You want to tell something?
Yes, Nandi. I just wanted to find out can a non-technical person can do this is what I'm asking.
Yeah,
Because
yeah,
I'm
yeah.
not into this earlier. Can we learn this from a scratch?
Sure, sure, sure. Today it's the beginning of the session. So we can learn the thing from the scratch itself. So you can learn the SQL, you can learn the Python. The particular course is totally very much starting from the basics. So if
Okay.
there is any stuck point while learning, I'll be asking the questions between each of the slides or two or three slides. Please ask me questions. And at the
Sure.
end of the session, there should be some time. I'll be asking you what are the stuck points and what things you haven't understand. Today and tomorrow, it's totally very much basics. It should not be top up any technical things. When we'll be learning SQL part, it should be a bit technical. We need to learn some coding on top of SQL, but that should be also starting from the beginning over here. Okay, so
Oh,
that there
sure.
should not be any issue.
Sure, sure. Actually, I'm not from a technical background, so I might find it a little difficult. So that's the reason I just wanted to let you know this.
No, no, no. You should not be find it difficult. Okay, it should be for everyone. Maybe whoever is already having experience, just like I know Soumya. Soumya joined from the, mid of the previous session. So she already have some experience, but I think you can tell that how much basics it should be. So maybe it should be bored to him that it why it's too much basic. But we can say it's totally, whoever will be starting the thing from scratch, it should be very much easy to grasp it.
Thank you. Thank you so much.
Okay.
Yeah.
Okay. Yeah. Let's start. So I think what is data? Data, we know all data. Now I'm just uh, diving into what we can go ahead with this. Okay. The purpose of data engineer that I told you. So the data we are collecting, just like if you are just entering any shopping mall, they are getting our information. We are putting our phone number as a there should be a customer ID or any other thing. And what are the purchase we are doing, the billing information, everything. So they are collecting the information in somewhere, in some repository, or they are doing something. But what they are doing with that data? So data engineers are coming into the picture. They are doing this thing in backend. Okay, what they're doing, I'm not telling today. It should be covering in next slides. Maybe we can tell it in business intelligence. So that is the purpose of data engineer. Actually, they are transferring it to meaningful data so that business owner can take easy decisions in their future business. Okay, so data engineers, if we are joining in a role of data engineers in any company, so we are preparing the source data. Source data means what we are collecting from the source side. So source side means, suppose you are going to a bank. Okay, so there your transactions and all, you should be having a customer ID. You are going to a particular branch and your credit money, your debit money from your particular account. What is your, motto, whether you are doing a investing on that particular bank or you are getting salary to the bank and you are investing some other bank, or this kind of information they're trying to collect from the source system by the input from the banking machines. And after that, in backend, the data engineers are doing something. They're converting this data into meaningful data and presenting the same to in front of business owner. Okay, who is owning that company? Then, if they are checking that you have quite enough money to invest and you are quite rich over that in their particular bank, they're coming to you with a phone call with the same bank that for a personal loan offer, for a credit card offer, because you can afford that particular stuff. So they are checking also by their data whether you have a, uh, you have a particular requirement for a credit card for your own maybe business or for your own family household matters or anything. So uh, this is the data engineers. The back end. Why? How they are preparing the data from a meaningless data to meaningful data. That is the main work of data engineer. Okay, so their work is to present the data in front of business owner such a way so that they can take easy decisions. Okay, I hope there is no issue. And what kind of enterprise? If we are just going to a live company to work on top of data engineer, this kind of industry you can see over there, just like banking industry, that is called banking and finance domain, commercial industry, insurance industry, medical industry, pharmaceutical industry. Each of the industry they are hiring the data engineers for their business growth. Okay, so maybe it's for their everything. The main motto of the business should be they want to grow their business. They want to check their competitors' performance as well, what they have done, what their competitors are doing. So how to beat their competitors, what extra products they are selling. Everything. There should be large of data for each day's transaction. Okay, so it's very hard to get the hidden pattern. So what particular hidden trends are there so that one company is getting higher growth and other companies having less growth. So data engineers can easily show it up in front of the business owner and they can take easy decisions. Okay, so in each of the industry, those are the big industry are using in every aspect they're using data engineers. So lots of things. During COVID, lots of new companies has been. They have their growth for the vaccination purpose. Uh, so for medicated product, the prices of the instrument and how they're selling it to hospitals. What are the money can be received by medical representatives? All there are lots of data. Okay, lots of data are there based on different requirement. We are collecting the data from the source system and pushing it to target system. Not only pushing, we need to convert the data in meaningful way and pushing it to the target system. Okay, all the things, the business intelligence part should be covered in next week in business intelligence chapter. But just a basic overview, what data engineers are doing, they're just transferring the data. They're collecting the information from the source system. They're transferring the data in the required manner and they're pushing it to a target system where the particular data scientist can access the data. The visualization engineer, they can create charts and graphs on top of data so that business maker or business owner, they can easily take decisions for the next days. What should be the strategy in the very next day, what they need to do, what they need to remove from their business. Okay, this kind of stuffs. Okay, now it's a bit technical, but no need to worry about it, Samantha. So if you are facing any doubt over here, you can quickly ask me. So
Sure, sure.
data can be segregated in two manners. Okay, one is relational database, another one is non-relational database. So we can see over there in this pictorial diagram, there is a tabular data having name and email as two columns. The first one, we have two columns in a particular table. That is called table. Okay. In a table, the first diagram I'm referring, there is name and email, two columns, and two rows are there as well. The first row is Ram, and its email is ram21@gmail.com. And the second name is Bob. His mail ID is bob32@gmail.com. So we have two records only, but we are storing the data in a tabular structure having two columns. The same information can be represented in the below manner as well. It's just like it's called a JSON format. It can also be, stored in other just like XML, YML. So those kind of format we can also store the data. It's just like name Ram, email ram@gmail.com. Again, the same kind of repetition, but changing the main content in the second. So here we are not maintaining the tabular structure, not storing the data in columnar format. The first set of data, it's called the relational database. So in relational database management system, we'll be storing data in this kind of format. There should be table. Inside the table, there should be columns, variety of columns, and we are inserting rows or records. Rows and records are same. We are inserting one by one records over here. Okay. And over here, it's called non-relational database. We will be just inserting the records in this manner. Suppose we want to incorporate a new columns over here. Suppose date of birth of Ram. Okay. So we need to introduce in relational database, we need to introduce a new column first. Then we need to insert that particular record or update that particular record with inserting the new data for date of birth. Okay. But over here, no need to update the table structure because there is no such table is available. So whose date of birth is available, just put a comma and put DOB. So its DOB should be the key and there should be a value. In non-relational database, the data can be stored in key value pair. Okay, the first thing is called key and the second thing is called the original value because this is the value, correct? That we required. This is the main business data that we required. So key and value. Non-relational database should be consists of key value structure. Okay. I hope there is no doubt in this slide.
Nandi, hi.
Yeah, tell me.
So
Hi,
in the
Pratisha.
second, hi. In the second image, we are just importing some data, right? That will be done through text file or XML file.
Yeah, we can do anything. We can do this thing by text file as well. But in text file, this is just, I'm not importing as of now. I'm just giving you an example how
Yes, yes.
non-relational data looks like. Okay.
Okay.
So import export part will be coming in data engineering classes. That should be a bit high. How to import data from other source system and all. So just like for give you a basic example, how non-relational data should be looks like. Yeah, if you are using an XML, the XML data definitely looks like in this manner. So you can
Okay.
see XML file should be consists key value pair. So if we want to transfer a relational database to non-relational database, we can import in this manner. We can also import a text file as well, and it should be looking like in this manner as well. So it's basically, how we are importing and what should be our target system. Based on our requirement, we can import export. But
Okay.
I just want to convey that relational database should be looking in this manner and non-relational database should be looking in this manner. Okay.
Okay.
Okay. Okay. Moving to the next slide. Okay. So here it's a basic introduction how relational data looks like. So yeah, it's a big thing I have written over here. Just to I'm just reading it out and you can just get some information. Relational database, or it can also be told as relational database management system. That is called RDBMS. Might be if you are a student or if you have already qualified any engineering graduate degree, might have learned RDBMS as one of your semester subject or topic. You might have, you might not have, because this is specifically on top of relational database. That the first one, the database on top of the relational database. It's called the Relational Database Management System, RDBMS. So it's mainly storing all the information in tabular structure, in tables. Okay. So this table shared information between them, causing a relationship between multiple tables. So why it's relational? It's setting relationship between multiple tables. Okay, inside a particular database, a database can be consists of multiple tables, and relational database have the capability to set up relationship between multiple tables. Okay, so we'll be checking how the relation can be set up in next slides. And while setting up the relation, we should be having a table should be having a primary key. And what is primary key? For a particular table, suppose I'm just storing employee related information for a particular organization. Okay. So over there, a particular column identifier, suppose employee ID. Employee ID should be unique for each of the record. That cannot be duplicated in nature. So employee ID columns can be told as a primary key. So in relational database, each of the table should be having a primary key. Okay. And the other tables should be having, the main table should be having primary key, and the other table should be having foreign keys. What is primary key and foreign key? I'll be just quickly coming with a pictorial diagram so that you should not be having any doubt. But if you have any doubt, you can tell me. So I just told the main table should be having some primary key, and the other table should be having foreign key. Based on primary key and foreign key, we can set relationship between multiple tables. Okay. Yes, we have an example over here. So in that example, we can see this is the customer table. Okay. For customer table, customer ID is the primary key. Okay. There is customer date of birth, particular order for that customer's address ID. But customer ID is the primary key of the customer table. Just leave the concept of foreign key as of now. Just concentrate on the primary key for each of the table. So customer ID should be unique for each of the customers. Okay. Now I'm going to the order table. In order table, order ID should be primary key for order table. Okay, there are other columns too, product ID, date. For address table, address ID should be primary key. There should be other column just like line 1, pin code, that can be duplicated in nature. Okay, just like customer date of birth, it should be duplicated. There'll be no issue. Particular product order ID. For order table, order ID should be unique, but product ID can be duplicated. We have, another order having, and they are purchasing the same product. Okay. So the product can be duplicated in nature for this table. Now we are going to product table. In product table, product ID should be unique because we are just storing all the product related information. Each of the product we are giving a product ID. So in product table, product ID should be unique. So each of the table I can see the first column are unique in nature for that particular table. And specifically to declare a primary key, we generally push the primary key at the first column. Primary key should be the beginning of each of the column. Okay. So any doubt for the primary key concept? Customer ID is the primary key for the customer table. Order ID is the primary key for the order table. Address ID is the primary key for address table. Product ID is the primary key for product table. Okay. Now, what is foreign key? In the particular customer table, there is order ID as well. Order ID is not the primary key for the customer table, but it's a foreign key. Foreign key means order ID is the primary key in order table, and it is been treated as foreign key in customer table. Same thing for address ID. Address ID is not a primary key in customer table, but address ID is the primary key in address table. So we are introducing these two columns over here in customer table to set up relationship between this other table. We have common column. If we have common column over here between each of the table, in customer and order table, there is common column order ID. If we have common column, when we will be learning SQL, we can join the two tables. Okay, how we can do joining part, we will be learning this thing later, but just keep in mind that we must need a common column to set the relationship, to set the join. Okay, for customer and order table, order ID is the common key. So on based on that, we can set the relationship between customer and order. The same thing for customer and address table, we can set relationship based on address ID. Okay. Now coming to this below table. So in order table, we can see product ID. Product ID is over there as well as a primary key. We can set relationship between these two tables based on product ID. Now we have a relationship between customer and product as well by this link. Okay, so order is the intermediate table, will be helping you to set up relationship between customer and product. So that is why it's a relational database. So we can set relationship between tables. We can get information from this table to this table by this link. We'll be learning joins in SQL. When we'll be learning SQL part, there we can see how we can fetch data from this table to this table. Any doubt till now?
No.
Okay, Samanthya. And anyone, Pratusha, I think you were asking. Soumya, I believe there will be no doubt. You were quite.
No, I'm good. I'm good.
Okay, okay, fine. So I hope.
I don't have any doubt.
Okay, fine, fine, fine. So that is why it's relational database. Okay. How to handle the relational database? That is called, I was calling SQL or SQL, anything you can tell. SQL, the full form of SQL is structured query language. So how to handle the data in the table? So suppose this is the table name, we need to write this kind of language. I'm not going to the language as of now, just check it. This is one kind of language to visualize the data or to manipulate the data. So these kind of things we'll be learning after 2 days from very basics. So, I mean, do not be worried. Just take this mind what is SQL, or it's also called SQL. The full form of it is structured query language. By SQL, we can do or we can traverse the it's relational database. So to read the relational database data, we have to understand SQL query or SQL languages. So this kind of language we will be learning there to solve our data related issue, data related problems and all. Okay. So starting from, okay, tomorrow should be one more introductory, not exactly introductory session, informative things for normalized data, denormalized data and all. It's very much important concept as well. After the third day onwards, we'll be learning what is SQL, how to write this kind of things and how we can see the data in more meaningful way. Okay, now it's time for non-relational database. First of all, a quick introduction. Just like going forward, we'll be not touching non-relational database because as per our courses, we'll be just learning only SQL data. I mean, relational database. And on top of relational database, we'll be learning SQL queries and all. Okay. So I'll be just suggesting a quick go through what is the difference between SQL and NoSQL based on the applications. So there is various applications of non-relational database as well. But for the data manipulation or data analytics perspective, especially relational database can be used. Okay. For data traversing, for quickly traversing data for some quick purpose or quick credential authentication method, the backend should be non-relational database. But especially for data analytics purpose, we should be using relational database, data analytics, data engineering. Okay, so this particular course should be mainly focused on relational database. So coming from tomorrow onwards, we'll be only focusing only relational database. Okay, so just like I told you, what is non-relational database? It should be storing the data as a key value pair. There should not be any tabular structure, no fields, no columns, no structural way of storing the data itself. Okay, in a particular structure, you can see one key is added, but in the next next row, you can see that particular key is not added because there is no data for that particular key. So it's not structural in manner. Okay, and it's called also NoSQL. Just like SQL, it's not only SQL. So it's called NoSQL. By NoSQL, we can traverse the non-relational database. Okay, a basic example how it should be looking like. You can see we can store the data in this format. It can be a JSON. JSON, I hope you what is JSON. You can, just search with JSON over here. JSON is a JSON. JSON is a non-structural database. It's a storage system. So how JSON should be looking like? Just I'm opening Wikipedia. Okay, let me open the W3 school over here. Okay, so this kind of JSON is, as I told it, it's a non-relational database. It should be looking like this. Even if you are just quite aware of XML language, it is also non-relational database. XML. Just open what is XML. Even any Java point or anything or any tutorial point, how XML should be looking like. Okay, so it should be also looking like in this manner. Okay, in this manner. First name should be first name. Okay, first name it's a opening brace. We are putting first name and then we're closing tag first name. So it's also just like key value pair. This is key, this is value. So this kind of thing we can see, we can say as it's a non-relational database where we are storing the data in tabular structure, non-tabular structure. It should be key value pair only. Okay. So here is an example you can see, just like this is, we can tell this thing as a JSON data type, or it's an example of NoSQL or non-relational database. Okay, I hope there is no doubt. If there is any, please tell me. Okay, moving to the next slide. Okay, now one more thing. So suppose we are representing the data in this manner. So there might be some visualization team who can try to convert the same relational database in pictorial or some diagrammatic manner like this way. And when we are just finally representing the same thing in front of business owner or decision maker, anyone, we can convert this particular relational database in graphical way. Okay, we can convert the things in charts and graphs in this manner. Okay, just you can see the same thing can be converted over here, no change. It's only the graph. I have converted the thing in a graph. But if I show both of them in front of a business user, then he or she can prefer only this one because it should be easily understandable. The data can be easily understandable. They can forecast something what should be next year's data and all. Okay, but Okay, one more thing. So when we will be storing data, it should not be this much data. I mean, this is just an example. So the data volume should be very big. But if we just consolidate the thing in a charts and graphs, that should be easily understandable. Okay, that is one more reason we are converting the relational database at the end. But I mean, we are whatever manipulation and everything we are doing at the SQL side in relational database. But when our data is ready, when our meaningful data is ready, we can convert the thing in charts and graphs and present the same thing in front of business user. And they can take their easy decisions. Okay. Okay, I have an example over there in Excel actually. Okay, this is the Excel. Yeah, so I just take this example. This is a relational database. There we have 3 columns: product, price, discount. Okay, let me just increase the size. Okay, so product means product name should be there. Their price should be there. Discount should be there. On top of price, the discount is there, and final price is there. That should be price minus discount. Okay, it's been stored over here. Okay, now how to convert it? We can convert the data into these charts. Okay, now showing the charts and graphs, it can be easily easily one can check what should be the prices and what should be the different measures by checking these charts and graphs. How to check that thing? Just we can quickly convert charts and graphs. Just select it. We have the insert. There can be multiple options. Okay, on various recommendation as well. We can just convert the thing in this manner to or any other. Various shades are there, but various just like bar chart is there, pie chart is there, various charts we can choose, but based on a particular thing, how it can satisfy a customer's desire or what should be the requirement, how user can take easy decisions. So data engineer should be checking that one, and the visualization team should be also coming under data engineers. There'll be no doubt, but the specific team should be there to convert the thing into charts and graphs. Okay, the specific team, it's also inside the data engineers. Okay, someone take the job role as a ETL developer. What is ETL and everything will be coming later. They will be mainly handling the data from source data to target. Some of the data engineers, they take the role of as a visualization engineer. They take this data, the final data from relational database, and convert it to charts and graphs. And after that, business decision owner can take decision on top of charts and graphs. Okay. So this way we can convert the data based on which particular requirement it requires. Okay, moving back to slide. Okay, so just like I have just provided you the example in top of Excel, but in your company, you should not be checking this thing in Excel. I mean, that visualization things and all, because Excel is just for our practice purpose over here. Big data, maybe we are converting millions of records data into a particular charts and graphs. So we cannot store even those many records in Excel. The Excel can be hanged. Okay, and there should not be 2 or 3 records. There may be lots of, 2 or 3 records or 2 or 3 columns over there. There may be lots of columns and lots of records should be available. So we need to think about a visualization tool that can be handle the business. So that, those are the different visualization tools available in market. That is called Tableau, Click. In Click, there are Click Sense, Click View. There are Power BI. This is a Microsoft tool. There is Cognos. So this kind of tools are available over there, and we need to we can get into accustomed of any of the one, and we can work on top of that too. This is different kind of visualization tool. Okay. Yeah, that's all for today's session. So what is relational database, non-relational database, how the data can be represented at the end in front of business, we have learned today. From the next day onwards, we'll be just, uh, I mean, we'll be just going more deeper way on top of relational database only. Okay, how the relational database can be formed and handled. And the very next day, we'll be just starting the SQL part, how the SQL thing will be doing. I mean, we will be handling the thing, but I'll be installing some software for checking the thing. It should be open source, free software. So I'll be requesting all of you to install the same thing in your system. It is very minimal space required in your system. So everyone can just install it. It should be hardly take 15 to 20 minutes for all the installation and setup. So just to understand the SQL things and all, please install the same thing. Tomorrow I'll be giving you the guidance how to install and how it should be working and how it should be looking like from user interface perspective. So tomorrow onwards we'll be just entering SQL or the more relational database kind of stuffs. Okay. So yeah, any doubt from anyone till now? Whatever we have learned.
Hi, I joined the meeting lately. I had some network issues. So where can I find the recording of the meeting?
Okay, I just started recording over there. So after completion of the recording, I'll be handing over the recording to the admin team, and they will be storing the same record in YouTube channel. Okay, a YouTube link. So I'll be just giving the same thing to them, and hopefully they will be updating the same thing. I'm not sure whether they'll be updating it by today or the day after tomorrow. But I'll be requesting this thing to as early as possible. If you get it from YouTube link, it's fine. If you aren't able to do that thing, I'll be sharing my OneDrive link so that you can take it from there only. Okay.
Sure.
Just wait for
Thank
some more hours. I'll be just handing over this recording to him, and you can check it from there. Okay, there is no much till we have learned today. So it's totally a basic introduction. But yeah, till if you just want to go through it's you can just quickly go through that thing.
Yeah, sure. Thank you. Thank you.
Okay. Any other doubt from anyone for this introductory session? Nothing? Okay, let's connect tomorrow with more details, more detailed manner as well. Yeah, anyone wants to tell anything? Harish, you're trying to tell anything?
Hey, hi. I would like to know whether you can provide me the data map for roadmap for the data engineer, so I can get to know what all tools or what all languages required to learn, to become a data engineer. So I get some clarity on it.
Uh, yeah, actually, this course covers. In the beginning of the class, I just told you. Let me check if I have any roadmaps or syllabus over here. No, as of now, I prepared an Excel there. Let me see it's updated or not. Okay. Especially for these crash courses, the thing should be in this manner. Okay. So the introductory classes, we will be learning RDBMS, what we have covered today. And tomorrow, I'll be covering on top of RDBMS some more topics. I mean, normalized data, how the data can be normalized and all. That thing will be learned tomorrow with some more example and exercise too. And the very next day, we'll be learning SQL. Okay. In SQL, those many topics should be there. 1 or 2 more days should be on top of hands-on as well. After that, we'll be learning business intelligence. Some swapping part should be there. business intelligence. What is business intelligence? That means the procedure to make the data from a meaningless data. I mean, from meaningless data to meaningful data. How to convert the thing, and how we have to store the data from the source system to target. So this thing will be learning in business intelligence topic. After that, Python should be coming into picture. From 2 or 3 days, Python basic should be there. After that, we'll be learning how Python can be used as a data engineer's tool. Okay, Python can be used in a multiple purpose. It's a programming language. It's an open source programming language. It can be used multiple purpose for multiple, solutions as well. But our main focus should be on top of data. How we can handle Python as a data engineer's tool. So there on top of Python, we'll be learning pandas. We'll be creating data frames and all. So Python classes should be there. Most likely 7, 8 total classes should be there for Python. After that, those 3 topics should be, it should not be a vast thing we'll be covering over here. Some basic touch base, because if you are just onboarded in any project, you can see you have to work on top of cloud. Maybe it should be AWS or Azure or anything. Just to give you a basic scenarios or basic example, how AWS, how you can how you can work on top of AWS in console. Suppose you have already console access and all, how to check the components and all. So there is some basic introductory session on top of AWS. Then some concept on top of big data, that is Hadoop. As of now, we haven't go through any particular hands-on exercise on big data for our system architecture and all. We do not have such tool over here. Even the open source tool I have tried install over here, but it's not working in my system configuration. So there should not be any hands-on, but I'll trying to convey as much as possible with code snippets in PPTs and all, how the things can be solved and what are the main functions and what are the main features in big data. And after that, some overview on top of Git. So whatever code we are doing in SQL or Python or anything, any other languages, we need to store the thing in some repository that is called Git. Over there in each of the company, they're using this thing, and that can be accessible for everyone. So how we can handle in Git and what are the main features of the Git, main functionality of the Git, that thing we'll be learning as well. So, and some placeholders are there for hands-on exercises and all on top of SQL or Python. Okay, so this is the overall roadmap. It should be mostly 1 month or few days extras, or just like total 1 month if we do not have any holidays or anything for week 4 or week 5. Yeah. So this is the total thing we'll be learning in our courses. Okay, Harish.
Yeah,
Any doubt?
thank you.
Yeah. I think that a particular thing should be helpful for everyone to know what we'll be going to cover by this session and all. Okay, so that's all for today. Let's connect tomorrow. We have some more clarity on top of relational database, how the tables can be handled, and it should be more interesting from tomorrow's sessions as well, when we'll be just going ahead a bit technical stuffs. Okay. Okay, then. Thanks all. Thanks everyone. Bye-bye.
Thank you, Nandi. Have a good day.
Thank you.
Thank you.
Thank you.
Thank you.
Thank
Thanks
you.
all.